Today we're going to discuss the calculations for the titration lab. As you recall, you took a burette and inside one burette you put HCl. This was actually a 0.05 molar HCl. And then in another burette you took NaOH, sodium hydroxide, but this one you didn't know what the molarity was, and that's the whole point of this lab, was to find out what that molarity was. So the first thing you did is you filled up your burettes with the acid and the base. So let's say that this one started at 0, and let's say for some reason you just filled up the NaOH up to 1. So that was 1, that was 0. Now you were supposed to take 5 milliliters of the acid. Okay, so this was a 0.050 molar HCl. So to take 5 milliliters, you would have had to make this go down to 5.00. So you're starting with the 0.05 molar HCl, and you started at 0 milliliters, and then you went down to 5.00 milliliters, so the difference is 5.00. So you used, for the first trial, in my example, 5 milliliters of the acid. So you delivered this into the Erlenmeyer flask. You put in 2 drops of phenolphthalein, or 1 or 2 drops, just so it would change color once you added the base. So now you took this over here and you have it ready, and you're going to add the base to it. Of course, you have the phenolphthalein still in here. Okay, so if you started your volume at 1 milliliter, and let's say you titrated it and you were done titrating at 10.35 milliliters. So your base started at 1 milliliter, and then you titrated to 10.35 milliliters. So the difference here, of course, is only 9.35 milliliters, because that's the difference. So that means you would have used 9.35 milliliters for this. Just by looking at this data, you should understand something about the concentrations in comparison. This only needed 5 milliliters, this needed almost 10. So that means that this NaOH is not quite as concentrated as the HCl. So now what we're going to do is do the calculations to figure out how to find the final answer. So we're going to move this up and look at an equation that we have, which is normality of acid times volume of acid equals normality of base times volume of base. So normality is very similar to molarity. Let me explain the difference. Since this only has one H in it, then every time you dissolve this you only get one H, so the molarity and the normality will be the same. Also, you only have one hydroxide in here, so one hydroxide there will make the normality the same. Okay, when we talk about the homework worksheet, I'll explain when they can be different. So for now, in this lab, they're the same. So let's copy down what we know. The normality of the acid is 0.05. So let me write that in red. 0.05 normal, which was the same as the molarity. The volume of acid we used was 5.00 milliliters. Then we know the volume of the base we used was 9.35 milliliters. And now we need to algebraically solve for the normality of the base, which comes out to be 0.027 normal, which would be the same thing as 0.027 molar. The molarity and the normality are the same for the acid and the base. Okay, so that's the first trial. Now let's suppose we do a second trial. And let's suppose in our second trial, I'll go back up here, and when we delivered the acid from the burette, let's suppose that we went down to 10.10. So 10.10. We didn't quite hit it exactly, so that's fine. When you subtract these, you're going to get a 5.10 milliliter difference. So that's how much acid you used in the second trial. Then let's suppose you used the base to titrate it, again phenolphthalein, etc., and you had 20.05 as your final volume. So now this difference is going to be 9.70 milliliters. So you're going to fill in your data chart for trial 2 as we just said. Okay, so for my trial 2, I still have 0.050 molar of this. Again, I started at where I left off the first time, 5.00. Then I went all the way down to 10.10. So the difference is 5.10 milliliters. My base, I started where I left off from the first trial, which was 10.35. I went all the way down to 20.05. And when I subtracted those, I got 9.70 milliliters of the base. So now we go to our formula and do the exact same thing. My starting molarity of the acid was the same thing as the normality, which is going to be 0.05. Just get the pen to work here. And the volume is going to be 5.10. So 5.050 normal, 5.10 milliliters equals the base volume, 9.70 milliliters, and we do not know the normality, but it's going to come out to be 0.026, which is nice because it's close to the other one, so we're precise. And of course, that's going to still equal 0.026 molar. Now I just simply need to take the average. So the first one was 0.027 from up there. The second one was 0.026. When you average these out, it's going to be 0.0265 as my final average. And that's going to be the average normality, which is the same as the normality. This will help you with the homework, which is coming up in the next part. Now we're going to follow up the lab with this worksheet as a practice of what we just learned. We're going to talk about the difference between molarity and normality. So if you have an acid like HCl that has only one H, the molarity will be the same as the normality because there's only one H. However, if you have an acid like sulfuric acid with two H's, then every time you have 2 moles dissolved per liter, you double the amount of H's because it has 2 H's. So this is going to be a 4 normal H2SO4. Bases work the same way. This has only one OH, so 1.5 is just going to stay as a 1.5 normal because there's only one OH. But if you have double the amount of OHs, then every time you dissolve this, you get twice as much. So you really have a 3.0 normal solution. So let's take an example of number 1, which is fairly simple, and then number 3, which is a little more complicated. All of these are going to use the formula NaVa equals NB VB. You really need to work in normality to make sure you don't mess this up. So the acid, we said, is 35 milliliters of acid. So that's going to go right here, 35.0 milliliters. Then we got the base. We have 55 milliliters of the base, so that goes right here. This is exactly like the lab you did. And then the base was 2 normal. It was already giving you the normality. And anyway, the normality is the same because it only has one OH. And then all you have to do is use algebra to find the normality of the acid, which is going to come out to be 3.71 normal, which actually would be the same as the molarity if they asked, because HCl only was 1H. So the molarity and the normality will be the same. Now a tricky one would be number 3. So let's do that one together. NaVa equals NB VB. So we know that the base has 73 milliliters. So that's going to be over here, 73 milliliters. We know that the acid had 145 milliliters used for the titration. So that goes over here. Now they're telling me it's a 0.45 molar H2SO4. There are 2 H's in there. So you actually have to double this molarity. So that's going to come out to be 0.90 for the normality. Then, when you go over here, you're just going to use algebra, and you should get an answer of 1.79 normal, which will be the same as the molarity if that were asked, because this is, remember, NaOH right here. So only one hydroxide, so the normality and the molarity would be the same. And you should be able to now do the rest of the worksheet on your own.